Welcome to our discussion of the shapes and the structures of bones. So, our focus in this section is going to be able to describe the major functions of the skeletal systems. The skeletal system is going to include not only the bones of the skeleton, but also cartilage, ligaments, and other connective tissues. And so, we're going to learn about the primary functions of that skeletal system, those big functions to support the storage of minerals and lipids. Yes, there are lipids in our bones. Um, Blood cell production, protection, and also leverage. Additional learning outcomes that we're going to cover is how to classify bones. So the bones are going to be classified by these basically structures here on their shape, on their structure, what types of shapes. You're going to find specific types of bone shapes. So sutural bone shapes, irregular, short, flat, long, and sesamoid. And so this is really important for you to understand how bones are classified and be able to know by looking at a bone what their classification is. So, for example, looking at sutural bones, you're going to find the sutural bones example in the skull. You're actually going to find these very, very small inserted bones in between the larger bones. And they also call them Wormian bones, too. And so they're oddly shaped. They're placed between the flat bones of the skull, which we can move on to the flat bones over here. The parietal bone, that's a perfect example of the flat bone. You also have irregular bones. They're irregular because they are of irregular shape. Just like you look at this vertebra, it is of irregular shape. Long bones are just that. They are longer than they are wide. Okay, so those are going to be considered those long bones. Short bones. Now, even though some of these might be longer than they are wide, your short bones, they're going to be more box-like in terms of their appearance. Last but not least, sesamoid bones. Sesamoid bones are usually going to be small, round, and flat. You're going to find them in joints, okay? A lot of times they're going to be encapsulated also, and so we're going to learn a lot more about those. It's really important that you can identify the classification of bones and be able to provide examples. And all of the bones that you are learning in this course, you should know essentially what type of bone that they are. Excuse me. So with that, your sutural bones, also called Wormian bones, like I said, they're going to be flat, irregularly shaped. You're going to find them between the flat bones of the skull. Uh, Depending on the individual, some might have more than others. Okay, so really depends on how this skull basically enclosed. Uh, During the time of growing from fetal into that toddler and then adult. So irregular bones. Also, this could also vary if there's any injuries too, but more so the first reason that I gave you. Irregular bones are going to have complex shapes, okay? Like for example, vertebrae bones, pelvic bones. So these are not going to have the same types of shapes and bony landmarks. They're just irregular because they don't have that typical types of shape. Your short bones, like I told you, are boxy. Your carpal bones of your wrist, your tarsal bones of your ankle, perfect example. Flat bones, they're going to be thin with parallel surfaces. Okay, I already gave you an example before of the bones of the skull, the parietal bone, your occipital bone, your frontal bone, temporal bone. And so those are really good examples, but that's not the only examples. You have bones on the skull, the roof of your mouth. Okay. I should say the skull roof, but um, also your sternum, your ribs, your scapula. Those are going to be examples of flat bones. Long bones, they're going to be long and slender. They're going to be found in your arms, your legs, your palms, so your metacarpals, your soles of your feet, okay, your metatarsals, your fingers and your toes, your phalanges. So those are going to be example of long bones because they are longer than they are wide. Your sesamoid bones, they are going to be usually round and flat and small. Like I told you a few slides back, they develop within tendons near the joints of the knees, the hands, and the feet. Location varies also with the number between individuals. Okay. Some individuals do not have the genetics to always make the smaller sesamoid bones. And so, uh, patella is going to be your quote kneecap. Just know when it comes to your exams, we call it the patella. All right, so it's going to be really important that you understand the markings of the bones. The markings of the bones are very important, okay? They could be projections that stick out. They could be openings and depressions that are basically going to invaginate in, right? Projections that stick out. Why would they stick out? Because that's where you're going to attach muscles and tendons and ligaments, okay? Also, you will find projections of bones stick out because those bones are going to articulate with other bones. What articulating means is that is the point in when one bone meets another bone, and they are going to basically have those articular passing of each other, and that is what is going to make the joint. So the openings and the depressions, we're going to get real specific with that. That's why I fumbled before. So like, for example, the hole, a foramen or a foramina. So those are going to be for passage of blood vessels and nerves. So if you see here, some good examples of projections. Process is a type of projection. It is basically a projection or a bump, okay? And then you have a ramus. A ramus is going to be a part of the bone that basically is going to form an angle. You can see it's angled with the rest of the structure. Okay, so they call that a ramus. In your bones, within those openings, I told you there's some more. You got sinuses, you got foramen, sometimes called foramina. Foramina is kind of really what they call the small ones, but they do really use them interchangeably sometimes. Fissure. Okay. You got meatus, you got your canal. So these are examples of openings. So a sinus is going to basically be the opportunity it's filled with air. Okay. So you have sinuses within your skull. It's kind of good because at least it makes our skull not as heavy. So that's a good thing. A foramen is going to be, or foramen, is I say it sometimes, you're going to hear me say it so I can spell it. And that's how I get my spelling just about darn at 100%. Okay. So it's foramen. It's going to be a rounded passage. See this little hole here? Got the hole here. You got the mental right here. Mental foramen. And then a fissure. A fissure is basically a slit. Do you see how there's a slit in the back of the eye socket? That is a fissure. A meatus is going to be a passage or a channel, especially the opening of that canal. Okay. It's just going to be the area in which it opens, a little bit different than a foramen. Okay. So this is going to be a more distinct type of passage or channel. Canal. Canal or a duct. You're going to basically find those. It's going to be a passage from one part towards another part. It's an even deeper type of meatus. So let's talk about um, the bone markings. So with these bone markings, so we talked about some of the bone markings here, some projections and some openings. We also have some depressions, other projections. These are projections where muscles, tendons, or ligaments are going to attach. And then also these are projections for forming joints. So as I look first, let's go through these depressions. So a sulcus is essentially a narrow groove. And so you're going to have a narrow groove in here. Uh, that is going to be your sulcus. A fossa is going to be a shallow depression. And so you can see here, right there, that's going to be a fossa. Um, all right, so with the projections where the muscles, tendons, and ligaments are going to attach. Some of these you're going to find are very similar throughout the bones, and some of them not. They might be specific to specific bones. But overall, we have kind of a generality of what these types of projections are. So starting with the trochanter is going to be a large, rough projection. So this right here. So a crest is going to be a prominent ridge. Okay. A spine, that's basically, see here, it's a pointed process. That's what the spine is going to be, per definition of spine. Don't confuse that with backbone type of spine. A line, so they call a line, that's basically a low ridge. Tubercle. A tubercle is a small rounded projection, and you can see that here on the humerus. Okay. Um, we can see we have a neck, we have a head. Tuberosity. A tuberosity is going to be a roughened projection right here. And so those are going to be the sites where muscles and tendons are going to attach. So let's look at the types of projections that are going to help to form joints. So a head, when you're looking here, the head of the femur is going to help to form the joints. It is going to basically articulate in the acetabulum of the coxal, or the coxae. And so with that, if you want to learn how to spell it, you can say acetabulum. Okay. But if you want to say it in public, you say acetabulum, acetabulum. Anyway, the neck. The neck is going to be a narrow connection between the epiphysis and the diaphysis. Okay. Um, Faucet is going to be a small flat articular surface. For example, this is going to articulate with the superior portion of the patella. And then you have your condyle. Your condyle, if you see here, it's going to be kind of underneath, is smooth and rounded. The articular processes, they're going to articulate with, in this case, the tibia. So you have a medial condyle, you have a lateral condyle. The medial is going to be directional towards the medial portion of the body, while the lateral is directional towards that lateral portion of the body. The trochlea. The trochlea, what that is, it's going to be a smooth grooved articular process and is shaped like a pulley. So this right here, these are the trochanters. I'm sorry, trochlea, the trochlea. My apologies. Alrighty, so with that, we've introduced these words, diaphysis, epiphysis, and metaphysis. Okay. You can say it how you need to spell it. How about that? So the diaphysis, that's going to be the shaft of the long bone. So there's your diaphysis. Okay. Epiphysis and epiphysis. And the metaphysis is going to be where the diaphysis and the epiphysis meet. Okay. So in your diaphysis, being the shaft of the bone, that is going to contain your compact bone. It's basically made up of the wall of the compact bone. There's a central space called the medullary cavity where you're going to find your bone marrow. In the case of adults, that is yellow bone marrow, which is essentially fat. It's essentially lipids. Okay. Um, in children, it is red, but it's quickly replaced with yellow bone marrow. All right, so with the epiphysis, you can say epiphysis if that helps you remember how to spell it. It is the wide part at each of the ends of the long bone. It is mostly made up of spongy bone, okay, also called trabecular bone because it has trabeculae. And the metaphysis Like I said, that's where the diaphysis and the epiphysis are going to meet, that junction. So here's a nice little picture. Okay. So the epiphysis, the metaphysis, the diaphysis, the metaphysis, and the epiphysis. So you're going to find your epiphysis and your metaphysis at each ends of that long bone. You got your compact bone, and then there's a medullary cavity in the middle. And the medullary cavity is going to be where you find your yellow bone marrow. So when it comes to the structure of the flat bones, so your skull bones, perfect example of flat bones. The flat bones are going to consist of spongy bone between two layers of compact bone. So let me back it up a little bit. Let me tell you about this. The thing about compact bone, it is very, very strong, extremely strong. Okay. But because you don't want the entire bone structure so strong and rigid that the bone could snap. You need spongy bone. You're going to find your spongy bone at the ends in the epiphysis. And the purpose of the spongy bone, well, guess what? You're going to find some red bone marrow in the spongy bone. So that's great. But in the spongy bone, because of the trabeculi, it is going to absorb shock. Okay, shock absorbing. So the great thing about the bones of the skull, it has two layers of compact bone for strength and spongy bone for some good shock absorbing. So that's a thumbs up on both of them. It's a win-win. So within that cranium, the large layer spongy bone is called the diploe. And so there you go. So the compact bone, and then it has the spongy bone, i.e. the diploe in it.